Alright guys, let's take a look at our lesson for today. We're going to look at derivatives using data. We are to the point, this is actually modeled after a free response question, and we have enough calculus knowledge in us now, I know after 3 weeks, right, where we can actually look at a model of a free response question. On the test in May, there's going to be half free response and half multiple choice, and they're worth the half free response is worth half of the points, and the half multiple choice is worth the other half of the points. So they're equally weighted. And this is just an example of a free response. So let's take a look. It starts by a prompt. Free responses have prompts like this at the top, and then they have different parts. There are typically 4 or 5 different parts to a free response question. So let's look at this one. It says that water is flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function w for 0 less than equal to t less than equal to 24, where t is measured in hours and wt is measured in gallons. Okay, so we have hours and gallons, and it's differentiable. Values of w of t at selected values of time t are shown in the table below. So this is typical. We have a lot of free responses. I mean, each year we have one with a table like this, a table of data. And what's really important for us to understand about this table of data is we are not allowed to insert any other data in it. We cannot use this and do a regression function on our calculator. We can't do anything like that. It's standalone data. We just have to use it as it is. And it's typically not evenly spaced out. This, usually the intervals are just crazy. This one happens to be a little bit nicer than most, but usually the intervals are just weird. So just expect weirdness. All right, and the context is basically water is flowing into a tank. That's our context right there. So that's what's going on. That generated all this data. Okay, part A says use the data in the table to find an approximation for w prime of 15. Show the computations that lead to your answer. Using appropriate units, explain the meaning of your answer. Okay, so first of all, let's make sure we understand what we have in the table. What kind of data is that? It is gallons. It's actual physical position data, right? At hour 0, we had 150 gallons. At hour 4, we had 184 gallons. It's actually physical data. It's a position. And they're wanting us to calculate a derivative. We don't have the equation. We can't use our calculator to find the equation, so we have to use a technique that we talked about before in a different context, and that is average rate of change formula. We're not really calculating the average rate of change. What we're doing is we're trying to approximate the derivative. So that formula, that slope formula, is really used for 2 distinct things. It's used to approximate a derivative in situations like this when we have no other choice, and it's also used to calculate average rate of change. So in this case, we're going to approximate the derivative at 15. Notice there is no 15 anywhere up here. So what we want to do is we want to find out where the 15 would lie in the data. So it would be right in here. And we're going to use the box on either side, the data on either side of where it should be positioned. We understand that's not even, 15 is closer to 16. We can't do any weighting, nothing crazy. We have to do just only what we see. Okay, just because it's closer to 16 doesn't mean that we do some kind of a weighting formula. It's just basically that's the data we have, that's all we can do. So we're going to use these 2 pieces of data to calculate our approximation of our derivative. So the computations, we're going to show that basically 294 minus 257 over 16 minus 12. And we'd use our calculator. This would be on the calculator portion of the exam. We get 9.25. And our units would be gallons per hour. That is a rate. A rate would have, something per something. And that's what rates look like. They have 2 units, gallons per hour in this case. So we've just done the first part of what they asked. We showed the computations. Units. Let's talk about units. Even if it doesn't ask for units, you need to put them if they're there. Typically, you'll receive a point for putting units on the AP test. So let's say you don't know how to do the problem. Well, write your favorite number down and write the units down. You're going to get a point. So it's worthwhile. I mean, units are a big deal. And if you don't put the units down, you're going to lose a point. So your science teacher will be very happy about that, right? All about units. So it's a big deal. Now, the last part is explain the meaning of the answer. And this is a specific, I mean, it's really kind of formulaic, the things that you have to put in. And I really suggest don't put anything extra. So let's see, what do we need to, I'm going to write my explanation down, and then I'm going to show you what parts are necessary. So at hour 15, the water is flowing into the tank. At a rate of 9.25 gallons per hour. Okay, so let's pick apart this explanation. If you don't have all of the parts of the explanation, you're not going to get credit for it, on a quiz or test, because you wouldn't get credit for it on the AP test. So let's look at what the parts we have. We have to be very specific. When. We have to know when. When are we talking about? We can't just say in general. When. At hour 15. We need to give context. This is a context. Water's flowing into the tank. What's going on? That's what's going on. So we have when, we have what's happening, and we have the rate. You have to have those three things in every single explanation on something like this, or you don't get full credit. If you leave off the hour, if you just say the water is flowing into the tank at a rate of 9.25 gallons per hour, you're not going to get full credit. You have to be very specific. Okay, so I'm training you to write exact specific words, not extra stuff. All right, how are we on part A? Is any questions? All right, let's take a look at part B. So part B says, use the data in the table to find the average rate of change for W of t over the time period 4 to 20. Show the computations that lead to your answer. Okay, so this time we're actually going to use the same formula but for a different purpose. We're using that slope formula, but this time we're going to use it to actually find an average rate of change. So let's take a look at what values they are. Now here we're required to use these values. On the other one, we had to choose which values to use. We had to choose the 12 and the 16. And we needed to be sure to choose those because that's what surrounds that value. Here, we're going to use the 20 and we're going to use the 4 because that's what they said to do. So let's do our computation. So we would do 327 minus 184 over 20 minus 4. We would put that in our calculator and that would give us 8.9375 gallons per hour. Okay, so let's talk about how we need to leave our answers. Our standard on the AP test is the thousandths. You may round or truncate. It is your option. Just go over what the difference between those. In this particular case, truncating would mean that I would just cut that off and my answer would be 8.937. I wouldn't even look to what's on to the right. If I'm rounding, then I have to pay attention to this number and I have to adjust according to what the number is. So 8.938. And those are the only two numbers that will be accepted for the point. Even if you're 1,000th off, you wouldn't get the point. So very important to keep all your numbers in your calculator and only round to the last, which we've been training you to do that for years, right? That's what you need to do. Keep everything in there, round at the last minute. All right, so let's make sure we did everything. We used the data, and we showed the computations that lead to our answer. Now, they didn't ask for an explanation. We certainly could write an explanation if we needed to, which would have this. We would say when. So between time equals 4 and time equals 20, the water is flowing into the tank at an average rate of 8.937 gallons per hour. We still have all those criteria. Is that okay? All right. Part C. For 0 to t to 24, must there be a time t when the tank contains 265 gallons of water? Justify. Okay, this should sound familiar to you at this point, I'm hoping. Right? All the theorems and formulas that you've memorized. What is that going to require? IVT, right? Intermediate value theorem. That's what it's going to require. And we have 3 parts. 3 parts to it. Right? And we have to talk about each of the 3 parts. On the AP test, do you have to label them 1, 2, 3? No, but you do have to talk about all 3 parts, so you might as well label them 1, 2, 3. So let's do that. So 1, we have to establish that it's a continuous function of time. Right? That's at the top, over the interval. So we would say the water is flowing into the tank. For 0 to t to 24 is continuous function of time. So like an application problem, we don't have an equation to look at to determine continuity. We have to talk about the physical thing, what's going on. Well, the water is flowing into the tank during that time period, and it's a continuous function of time. 2. What was our second one? Do we remember? Yes. Exactly. So we want to make sure the endpoints are not equal. The y values of the endpoints are not equal. And so for us, we're going between 0 and 24. So we would say, since this is already indicated for us, we can say w of 0 does not equal w of 24. That's part 2. Could you write 150 is not equal to 357? Sure. You could do that too. Either one is sufficient. Part 3. Remember, that's where we say the k value is between f of a and f of b. So in this case, our k value would be 265, right? So 265 is between, and I can say w of 0 and w of 24, or I can actually write, the number out, 150 and 357. It's my options. And then we know the conclusion is, therefore, there exists, a value c between a and b. So what we can say for this, though, we can say yes by IVT. The conclusion is the name of the theorem. You can write the name of the theorem, or you can write out the conclusion. Those would be your options. Because the name of the theorem says what the conclusion is, and that's acceptable. Okay? All right. Questions? Let's move to the second slide. So here, it's the same prompt. I didn't recopy it. It's the same prompt, and we are given a model. A model for the amount of water in the tank is given by A of t, and it lists, the model. This is where I'm going to work with you on some calculator input. Okay, so if you would have your calculator out, I need you to put this equation in y1. So go ahead and type this equation in y1, the 1 over 225, and then parentheses that whole thing. And I'm going to pull up my calculator. Okay, so I have that entire equation in my y1. It's kind of running off the page. That last number is 33,750 plus 33,750. So what it's asking us to do, we're going to be doing computations with this equation. And the quickest thing for us to do on the AP test is to go ahead and just input it in y1. We're going to use it a couple of times. You don't need to type it in multiple times. Type it in one time. So we type it in one time in Y1. And now we're going to go to a clear screen. Is everybody okay with that? Got it typed in? Okay, so now we're going to a clear screen. And we're going to do the computation they asked. They want us to find a prime of 15. They want us to find the derivative value of that function at 15. So we're going to let our calculator do it. Why do it by hand when we have a calculator? This will be on the calculator section. So Math 8 is pretty important to us. That's a derivative calculator. And Math 9 is integrals. Those two buttons are going to be important for us, Math 8 and Math 9. So here, Math 8, it pops up this derivative kind of template. If you don't have the new operating system, then yours won't look like this. If you need it, if you have an 84 or if you have an 84, I have an operating system that I could download on your calculator. But you just need to let me know. We need this because it helps us go faster. The new operating system helps us go faster. So dx, I'm going to put an x there. I'm taking the derivative of that function that's in y1. So if you recall how to pull that down, it was alpha f4. And see over here we have y1 highlighted already. So enter. So I'm taking the derivative of y1 and I'm taking it at, what was it, 15? I'm taking it at 15. And I hit enter. And there's my answer, 9. Which is kind of unusual. That's a whole number, but hey, it's a whole number. So what would we write? I'm going to actually write on this calculator screen. This is what you would be required to write on your paper. You would say a prime of 15 equals 9, and then you would put the units. 9 gallons per hour. That is all you're required to write on your paper. Because why? Because the function for a is already written on your paper. There's no need to write it again. If you call it by a prime, you don't have to write it again. Just say a prime of 15 equals that, you're done. Are we okay on that part? Okay. All right, so now let's look at the other part. Part E says, use the model given in part F. Okay, we're to our equation, our A of t equation again, to find the average rate of change of A of t over the time period 4 to 20. Okay, so some more calculator input. So let's go back over to our calculator. And we've done this before, if you recall, maybe last week or so. We want a fraction, so alpha y equals, enter. There's my fraction. And now I'm going to do my calculation. This is an average rate of change, right? I need y1. I need to pull that function down. So y1 is alpha f4, y1 of, open your parenthesis, put in the number, which is a 20, close your parenthesis, minus, we want y1, pull the y1 down again, so alpha f4, enter. Open parenthesis, it was to 4, and then close parenthesis, and in the denominator we're going to type in 20 minus 4. I really suggest that you type that in and let your calculator do it instead of doing that in your head and accidentally writing down like 18 or something. You know, you just don't let the calculator do it. So we have that written in, we hit enter, and it's in fraction form. Maybe we want it in decimal form, so I'm going to remind you how to do that. You probably already know. So if we have a decimal and want to turn to fraction, or have a fraction and want to turn into decimal, we go to math and see number 1 says 2 fraction, number 2 says 2 decimal. We want to turn it into a decimal, and that would be the decimal form. So you can go back and forth to determine what form you want it written in. So now let's talk about what you should write on your paper. So on your paper, and I'm just going to write it on the screen, the function name that was a, so we would say average rate of change equals a of 20 minus a of 4 over 20 minus 4, which equals 8.9955. I'm just going to write to the 10,000th, which you're allowed to do. It's okay. And I'm going to put my rate, which is gallons per hour. So this is what you're required to write on your paper. If you don't write that part, you're not going to get credit for your answer. Okay? That's just showing the formula. Are we okay? Yes? All right.